Hello friends. Today we'll talk about electrical discharge machining, or EDM. It's a special machining technique that shapes or cuts metal using electric sparks. There's no physical contact, the work is done purely through controlled sparks. Let's understand this in simple words. EDM is a special machining process that uses electric sparks to remove material from electrically conductive metals. It can work on very hard materials like titanium, tungsten carbide, or hardened steel. EDM allows us to create very fine, complex, and precise shapes that are hard or impossible to make with traditional cutting tools. How does EDM work? In EDM, there are two electrodes, the tool electrode and the workpiece. Both are immersed in a special liquid called dielectric fluid. When high voltage is applied between them, the dielectric fluid breaks down and a spark forms across the gap. This spark generates intense heat that melts and vaporizes a tiny portion of the metal. The dielectric fluid then flushes away the molten material, cleaning the gap for the next spark. This process repeats rapidly, creating the desired shape with extreme accuracy. EDM is mainly of three types. First, die-sinking EDM, also called ram EDM. Here, the tool electrode is shaped to match the desired cavity and is sunk into the workpiece. It's ideal for 3D shapes and making molds. Second, wire EDM. This uses a thin wire that continuously feeds through the machine. It acts like a cheese slicer, precisely cutting the workpiece. Perfect for 2D profiles and complex contours. Third, hole drilling EDM. This is used to create deep, narrow holes. Examples include cooling holes in turbine blades or injection nozzles. Role of dielectric fluid in EDM. Dielectric fluid is extremely important in EDM. It insulates the electrodes before sparking. It controls and cools the spark. It also flushes away the melted particles from the spark gap. Common fluids used are deionized water or special oils. Advantages of EDM. Can cut any hard, conductive material easily. Creates very complex and fine shapes. No mechanical contact, thin walls remain safe. Excellent surface finish and micron-level precision. Limitations of EDM. But EDM has some drawbacks. The process is relatively slow. Tool electrode wears out and needs replacement. Maintaining the dielectric fluid can be costly. Works only on electrically conductive materials. Applications of EDM. EDM is used in many industries. Mold and die making. Aerospace parts manufacturing. Complex medical instruments. Micromachining of tiny electronic components. Any hard, complex, and high-precision component manufacturing. Let's also look at a bit of history. The idea of metal erosion by spark was first mentioned in 1770 by Joseph Priestley. But the modern EDM process was developed in the 1940s by Soviet scientists Br and Ni Lazarenko. They designed a special circuit to control the spark, still known today as the Lazarenko circuit. So friends, this was a complete and simple introduction to electrical discharge machining, or EDM. If you found this video helpful, please like it. If you want videos on other topics, let me know in the comments. Thank you.